Hey, I have a question for you.
Hey, what's up?
What's the center of gravity?
I have no idea what that is.
Do you want to go investigate?
Alright, let's do it.
Alright, rack up.
In a uniform gravitational field, the center of mass serves as the center of gravity. This is a very good approximation for smaller bodies near the surface of Earth, so there is no practical need to distinguish center of gravity from center of mass in most applications. The concept of center of mass in the form of the center of gravity was first introduced by the ancient Greek physicist, mathematician, and engineer Archimedes of Syracuse. He worked with simplified assumptions about gravity that amount to a uniform field, thus arriving at the mathematical properties of what we now call the center of mass. In physics, the center of mass, or barycenter, of the distribution of mass in space is a unique point where the weighted relative position of the distributed mass sums to zero. The distribution of mass is balanced around the center of mass, and the average of the weighted position coordinates of the distributed mass defines its coordinates.
The center of mass of a system of masses is the point where the system can be balanced in a uniform gravitational field. There is one point in any system of objects that has a special significance, the center of mass. One of the reasons the center of mass is so special is the fact, in many ways, a system behaves as if all of its mass were concentrated there. As a result, a system can be balanced at this center of mass. The center of mass equation equals the first mass times the distance of that mass plus the second mass times the position of the second mass, which will be in the opposite direction of the first mass. All that divided by both of the masses, which equals the total mass. Then if the masses are equal, if m1 equals m2, then the center of mass will equal 0, because x1 is positive and x2 is in the opposite direction, so it will be negative. So they'll cancel each other out and it will equal 0. In the experiment involving forks balancing on a toothpick, the forks are both the same mass, 50 grams, and this distance from the end of the fork to the toothpick is 17 centimeters. So if we plug those two variables into our equation, we'll get 50 grams times 17 centimeters plus 50 grams times negative 17 centimeters, because one is positive, one is negative, they're acting in the opposite directions, divided by the total mass, so 50 plus 50 equals 100. So multiply that out, it's 850 grams per times centimeters minus 850 grams times centimeters over 100 grams. The grams cancel out. 850 minus 850 equals 0. And we get 0 centimeters. Dude, do you ever leave the weight room?
Gotta get paid for the ladies, right?
I mean, you're doing it differently this time. What's up?
Yeah, ever since we discovered the center of mass, my workouts are much more efficient.
So physics actually applies to the real world? Man, that's crazy. You need a spot?
Yep.
All right.